Today, I wanted to talk a bit about basically a grumpy programmer's guide to being a senior developer. For a little bit about me, some people might know me, they might not know me. I've been involved in the PHP community for a very, very long time, dating all the way back to writing my first bit of PHP code in 1998. So 23 years of programming, web stuff for the most part, mostly PHP. And normally, as Neil pointed out, I do spend a lot of time talking about testing. For once, I'm not going to talk about testing. I'm going to talk a bit about sort of how when you go from being a low-level or mid-level programmer to being a more of a senior programmer, kind of what you should be expecting is actually going to happen, because the job does kind of change. Because when I think about it, we start with this thing, so you've become a senior developer. And as we all know, titles mean a lot to some people and don't mean much to other folks. I think it's very safe to say that if you're given a label of being a senior developer, but you're not doing anything different, then probably the label doesn't mean anything and you're probably not a senior developer. But let's assume that, wherever you're working or you're accepted a new position somewhere and you're going to be a senior developer. So how did you get here? And what is it you're supposed to do now that you're a senior developer? What in my experience, changes when you become a senior? But I want to tell everyone, just, I know a lot of people, even a C-level internet superstar like me, sometimes feels like they're not up to the job. We have anxiety over doing work. We have anxiety over a new position. We have anxiety over, do I actually know what it is that I'm doing? But I'm just encouraging people, when you have this opportunity to move into a more senior role, take a deep breath. It's all going to be okay. Excuse me. I have allergies, so I may cough a little bit. Plus, combined with my really nasty Canadian accent, I apologize in advance. But it's all going to be okay. And eventually, you want to be like this when people ask you, why are you still working with PHP after 23 years? Because actually, in all honesty, the money is really good and the problems are really interesting to solve. So let's kind of talk about my perspective on, once you become a senior developer, it gets better for you, but it also gets worse. And in what ways does it get better? Well, my experiences have been, when you get to a senior position, hopefully you're moving one level up in terms of sort of the overall vision about the work that you're doing. When you're, for lack of a better term, junior or intermediate developer, you're probably focusing just on sort of, here's the one task that I have to do. It's been assigned to me, or, if you're working on an open source project, you've picked up a task. So, before, when you're not a senior, you only really have to think about one task. Once you move up to be a senior, you're going to have to start thinking about not just the work that you're doing, but the work everyone else that is doing. You think about it moving in terms of layers. You have, at the bottom layer is just one task at a time. The next layer up is thinking about, there's multiple tasks getting done in parallel that you need to think about. And then the next level up from that is, there's business goals that link in with all these tasks. So when you become a senior, you sort of lose that luxury of, I just need to worry about just the work I'm personally doing, because all of a sudden you're likely to have more responsibility. So always think about, you're moving one level up in that sort of vision of what's going on. But what way does it get worse? My own experiences have been, the things that you are likely not good at will become more exposed now that you're at a higher level. And to compensate for the fact that you're likely going to be asked to do things that you're generally speaking not good at, understanding what you're not good at is going to let you cope with that better. Let me kind of explain. When you become a senior developer, chances are you're going to go from reading, everyone's favorite ticket tracking system, Jira. You're likely going to start going from only reading Jira tickets to writing tickets. And if you're already writing Jira tickets, you're probably going to go from writing Jira tickets to verifying everyone else's Jira tickets. And my experience has been that most programmers are not out of the box great at the non-programming side of things. So once you become senior, you're definitely going to actually spend some time learning how to do the stuff outside of programming. I know this seems intuitive to people, but it really isn't. Your flaws will be exposed. All the things that you're not good at, you will be forced to deal with them. If you're not good at focusing in meetings, you're likely going to be in a lot more meetings, so you're going to have to learn how to pay attention. If you're not good at communicating things, you're going to have to get better at communicating things, or else your job as that senior developer on the team, you're not going to be senior for very long. This was my experience in the first half of my career. I went through kind of being the junior to intermediate person on the team. While I kept learning, I quickly understood what things I was good at and what things I wasn't good at, and I realized I was probably going to be able to keep getting opportunities to, keep doing the things that I'm good at, because despite our best efforts, teams inevitably get siloed. People on a particular team, you have the person who's good at the sysadmin side of things, the person who's good at the ops side of things, the person who's good at the front end side of things. It's inevitable that you get siloed. So part of being senior is that usually you're going to have to broaden the skill set. And this goes way past just worrying about the technical side of things. So once you've become senior, I would suggest work on your written communication skills. Definitely work on your verbal communication skills. Verbal stuff is even more important in the pandemic that we're in, where most meetings are like this sort of stuff. We're doing video presentations, we're doing seminars, we're doing informal chats one-on-one over video. Many years ago, when I was in college, I used to be terrible at the presentation side of things. I knew I was bad at it, and I just didn't see a way to get forward through that. And as luck would have it, I had to do a course on doing presentations where you had to stand up in front of a class and talk to a bunch of people. And at that time, I was definitely the person who had that sheet of paper and be shaking and stammering while I'm working on this stuff. But I don't know what it is the teacher who ran that presentations course did. The bits in my head got all lined up the right way. And I got to the point where I could very easily give a presentation in front of a room, do group presentations in front of my classmates. And that eventually became a skill that became very valuable as I worked on that path of going from programming as a job that paid really well to programming as a career, meaning that it was something that I wanted to work on improving all parts of it, to the current stage that I'm in, which is speaker, mentor, evangelist, teacher, that sort of stuff. And all along the way, what I learned was that you had to become more rounded and with all your skills, and also learn to identify what are the things that I'm not great at and how to get better at them. And most of that ended up being personal skills, communication skills. So when you move up, you're definitely the things that you're not good at will get exposed, because you're hopefully, as you become a senior developer, you have more responsibility. You're gonna have to worry about things more than just making sure your personal day-to-day work gets done. So as a senior, when I think about positions that I've worked where there's been senior people, whether I've been one of those senior people or I've been working with other senior level people, I've noticed a few common things that the senior people start becoming responsible for. The main thing I've found is that you need to start caring more than you did before. Because again, I've talked about this before. There's absolutely nothing wrong with the job of programming as something that can pay really well, that funds the life that you want to have away from the keyboard. I know I spend lots of time cultivating hobbies where I don't have to be in front of my computer all the time. And programming as a career is not for everybody. And there's absolutely nothing wrong with I like working with computers because I get paid a lot, and that allows to fund the life that I want to have outside of work. Working constantly is not healthy for you. It's good to have hobbies that don't involve typing into a computer. So, but when you become a senior person, chances are you're starting to move down that transition from programming as a job to programming as a career. And all of a sudden you'll find, in order to be successful at the programming as a career path, you need to start caring more about stuff, which means the dreaded thing where you might actually have to start caring about actual business processes. I know there are lots of programmers out there who feel like sales and marketing are terrible. They're not, people can't learn how to do that. They lie all the time. They're an obstacle to the business. They're selling features that the programmers are going to have to build without any regard to whether it can actually be done. One of the ways to combat that is, as a senior person, you're going to have to insert yourself into those discussions. You're going to have to start paying attention to what is it that myself and the other people that I'm working with provide to the business. Here's a good example. Previous place that I worked, I was working for a company that was doing lead generation for mortgages in the US. People would go to their website, fill out a bunch of information. Then this system that I was hired to help maintain and extend would then match excuse me, banks and other financial institutions to people who wanted to borrow money to buy a house, buy a rental property, buy a vacation property, anything to do with real estate. So the first thing that I did when I started working there in a senior role was actually talk to the people who ran the business side of things to say, what is it that you're trying to do? What is it that this existing system is not doing that you need it to do? And then furthermore, if things are lined up perfectly, what do you want the system to do? Because sadly, we're still in a point where we don't have universal basic income. We can't all be paid just given a check by our respective governments to like stay home and do whatever it is that we would like to. It would be nice, but we're still right now in this period where we're getting paid to do something for people. And in this case, I found it became a much easier job to do when I started understanding how business requirements get turned into technology. So you'll find at the senior level, you will have to care. You can't just, being senior doesn't mean I get better things to work on necessarily. It means that you're gonna have to pay attention to what the actual business does. The next thing that I have found that senior developers end up having to do is you're gonna have to start caring about mentoring other employees. In the, in the talk, when I was talking with Neil and Richard beforehand, it was like, we kind of talked about how part of the task that senior people have often is mentoring becomes, if not an official part of your job, definitely an unofficial part of your job. And, when you start attending, meetups like this or going to conferences and then speaking at conferences, you get a little window into sort of like a subculture of the programming community that you're part of. And you start realizing there's all these things that you didn't know you didn't know. So you get excited about learning those things. You learn those things, then you start attending more meetups and you start attending conferences if you've been lucky enough to go in person. And then you start, if you get really lucky, you can start speaking at conferences. And at the same time, the sort of window that you're looking through for another subcommunity starts shifting over towards the high end of things. So sometimes you can forget that when you only deal with people who are sort of at the same level of interest and desire to learn about certain parts of programming, you're not necessarily surrounded by people like that. So one of the things you're going to have to also get really good at is, how do I communicate the things that I know that will be helpful for the project to the other people I'm working with in such a way that I can get them to buy into it and believe the same things that I do. I think about my own area of expertise, which is testing stuff, automated testing being the big focus. Definitely worked at lots of places where they either had very few tests or no tests at all. And then, you can get really militant about it and demand that everybody do everything your way. It doesn't work unless you have absolute power in the workplace, and very few programmers do. Instead, we think about how do I get these people to care about things the same way that I care about them? So you have to start modifying your message for your environment. If there's no tests, maybe the first step is, okay, let's, every time we fix a bug, I need to see proof that the bug has fixed. Maybe that proof is you write out the 10 steps that you did on the web app where you logged in and clicked on this and created an account and did all these things. And this is how we prove that the bug got fixed. Or maybe it's some code that transforms a bunch of data in the database, right? Show people what's a good way for me to show that this thing worked. Okay, then maybe the best solution is I'm going to run a MySQL query And here's the results before the transform, run my new code, then do a query to show the same data has been transformed correctly. That is mentoring. That is showing people, here's an idea that I strongly believe in that will help us. And I'm going to show you not the specific tools, but teach you the specific mindset. Testing, to go back to it, is really about proving that something behaves as you expect. The ultimate goal is fully automated testing, that every change that you make to your code gets picked up by version control, a continuous integration system, then reacts to those changes, runs a bunch of tests. If everything is okay, then that stuff automatically gets pushed up into production. This is not a dream. There are companies that do this. Most people get as far as the triggered with a build system to do stuff. And then, my job is to help help teams get past that. So mentoring is always about taking what you've learned that can be helpful to solve the problem that we have, and find a way to apply it to your situation. Every situation is unique. Every code base is unique. Every test approach is going to be unique, because we are definitely not at the cookie cutter snap Legos together phase of programming. We're not there. Maybe we never get there. But as long as we know how to take knowledge about how do I prove something works and apply it to all sorts of different situations, as a senior developer, that is your goal, because that's kind of the goal. And the next thing you're going to have to also do as a senior level person is you're going to have to care about working effectively with non-technical folks. If you got into programming because you thought you could work away and have nobody bother you, that you're going to be locked away in a room or in a cubicle in the corner of the office and produce some sort of masterpiece and then give it to everybody else and it will work, that is not how it works at all. The best solutions I have seen in my bazillion years of working as a programmer have been ones where you are working effectively with the non-technical folks. And by non-technical folks, I usually mean the people who understand the business side of this application, right? Another phrase to describe this is, as a programmer, you have to learn domain knowledge, which means you have to learn to speak and look at things the same way that the non-technical folks are doing. To go back to that previous place where I was working, when we talk about lead generation, what was one of the things that we were having problems with? Well, the amount of time it was taking for the system to match a person's profile to what lenders what lenders match up nicely with them, because there was a business requirement. We want to have them get in touch with a potential lender in under a minute. So how do we get there? Where are we at now? What changes? What have they tried before? What didn't work? What did they change and did work? And sort of work on a plan with the goal being, how do we get this number lower? The people on the business side, they don't care that we're building this system in an older version of PHP with a really older version of a framework, and they don't care that the database is huge and hard to do things like pause things and lock rows to update indexes. They don't care about that side. They care about I need the system to behave in a certain way. How are you going to help me get there? So as difficult as this can be for a lot of programmers, the communication skills matter. The ability to use the same language that the business folks use matters. As a senior developer, you want to be that bridge between the business and the IT side of things. Because as a senior, when I talk about moving that one level up of vision, your job now becomes, instead of moving yourself forward and getting all your tasks completed and not really caring if your coworkers get their tasks done, well, now your job will become, you're trying to move the group forward. As a senior developer, I try to cultivate the idea that we are going to succeed as a team, and we're also going to fail as a team. I want to go out of my way to not hang out my other coworkers to dry. I don't want to point fingers at people and blame people when something good gets done. I want the whole team to share in the success. And when something bad happens, I want the whole team to take the responsibility for fixing the problem. We're trying to move the group forward. As a senior, the idea is that with the reason you promote is that you have all this experience. And now sometimes it's a reward for length of service, or they don't want to lose you, so they promote you while they still get you to work on the same sort of things. This sort of thing happens. But now you want to be concentrated on, you want to move everyone forward. So this is where the stuff I talked about before comes into play. Mentoring, getting your communication skills up. Now you need to start doing things looking at business, looking at development processes. What are the things that are causing us friction? Are we standardizing on anything? Are we standardizing on the version of the language? Are we standardizing on versions of libraries? Are we standardizing on tools? Are we all using the same operating systems? Are we all using the same editors? Are we all using the same version control system? And within that version control system, are we all using the same tools? Are we using issues? Are we using tags? Are we using branches? We're wanting to look at every part of the development process and say, where's the friction? When I've worked at places, sometimes the job doesn't last forever, but usually what happens is that when you first start working someplace, there's a few things that cause friction. And as friction in your tools, friction in the language, even friction with coworkers, friction with how tasks are assigned. And as a junior to intermediate level programmer, you probably don't have a lot of say over that stuff. But all the frictions build up over time. And when you get enough of them, it goes from just being a friction to a humongous flame or explosion. And this is when people start to quit. They don't feel valued. And especially with a lot of places, turnover actually hurts the team usually. You've lost people who are familiar with your processes, however good or bad they may be, familiar with the application, however good or bad it may be. And now, if you have people who are constantly unhappy and constantly having friction and banging up against processes and tools, well, then people are going to be unhappy. And when people are unhappy, they're likely to not care about the tasks that they're working on. And when people don't care about the tasks that they're working on, well, that's when all the classic things that senior developers end up struggling with happen. Technical debt, a lag on updating libraries, and ad hoc processes for everything instead of sort of standardizing on what goes on. And as a senior developer, the technical challenges become the big ones that we're trying to solve. And so you stop thinking about how am I going to accomplish this one task. We start thinking about how do we get to where the business wants to be from where we are now. Let's take an example. We have a super old PHP 5.5 application. We know this is not tenable because PHP 5.5, first of all, doesn't get any more security updates. So if we have public-facing code, and maybe we have a systems team, and maybe they're really good at the security side of things, maybe they're not. Maybe they don't know about security holes, but we have a super old version of the language. So we need to figure out a plan. How are we going to upgrade to a newer one? So then you have to start looking at, well, what are we doing? How could we pause? What are our opportunities that we could say, okay, maybe we could start thinking about, can we rewrite this application in place? Could we use something like the chrysalis pattern, where we're going to take an old crufty application, we're going to create a brand new one, temporarily create a router that runs all the requests through the old code, and then we just start updating things in place. Because once we can start moving to a newer version of the language, then we can start looking at some of our dependencies that we have in the application. Are there newer versions of this library available? Are there new versions of this tool available? What happens if we upgrade? If we do upgrade, how are we going to detect that anything has broken? So you go from again, at that sort of junior intermediate level, you're probably running into some of these problems, but you're probably not caring about them too much, because at the end of the day, you don't have enough, you don't have the authority within, whatever chain of command there is to say these things need to be changed. So you're going to be thinking about, okay, we clearly need to get using a newer version of PHP. How would we do that? If everything was perfect, how do we do that? Then having done that, okay, if we upgrade to a newer version of the language, what about our dependencies? will they still work with the newer version of the language, or do we have to think about how are we going to update? In many cases, you can't just upgrade from PHP 5.5 to PHP 7.4 and just type composer update and have everything work and everything not break. I mean, maybe you're really lucky and it works that way. My experiences in the real world have been, no, everything is going to break, and chances are you don't have enough, QA stuff in place to even know what's breaking and why it's breaking. So, a lot of your job, as you can see, your job becomes less and less about sitting in front of your computer with a development environment set up and coding. You're doing more high-level thinking. That's that vision thing that I talked about at the beginning. You're moving one or more levels up in terms of what you have to worry about. Your task as a senior developer becomes much different from I'm just writing code and closing Jira tickets to I'm now trying to decide, how do I upgrade PHP? How do I upgrade these dependencies? How do I migrate data? How am I going to migrate to the cloud? A senior level person has said we need to start doing stuff serverless. How am I going to wedge a serverless thing into our existing application? These are all super high level things that all of a sudden you have to think about. So let's talk about from that technical side, what are some tools that I've seen that actually help? A great thing is architectural decision records, where you start thinking about the thing that I've built, how does it actually work if I had to write it down for someone else to read? And then if we make a change, we should be documenting those changes that happen. Place I was working before, the financial services place, we started using these architectural decision records anytime we changed something to say, here's how the existing module of code works. Here's how we need it to work. So here's the changes that we're going to make. And then we wrote those things down in plain text and saved them somewhere where they could be version control. At the job that I'm currently working at, we do a similar thing where I'm working with a bunch of consultants. We're working for an American corporation. They're telling us we need you to do X. Great, we write up a proposal. That's a more formalized version of one of these architectural decision records. We're writing down the way things work now. We write down how the business wants them to work, and then we start writing down how are we going to get from where we are now to that. Things like we're going to need new code, we're going to need new tables in the database. If we're doing tests, okay, we're going to need new tests covering these scenarios that ensure that the new thing is behaving as expected. Architectural decision records are just one of the things you're going to have to start doing. You have to start writing things down. I know developers hate writing documentation. I've written, I think, 8 or 9 books at this point. I still don't really like writing documentation. I write documentation to protect myself so that future me understands what current me had to change what past me did, right? So start doing architectural decision records, start doing text files, start doing readmes, start doing guides, start doing upgrade guides, start creating a wiki, start writing things down so that you can then share those decisions with other people. Because sometimes the business is going to ask you, why was this change for me? We pushed a change, everything blew up, we roll everything back. We have the dreaded postmortem where we talk about why things broke and what we're going to do to make sure that doesn't happen again. Writing everything down, while I agree, it gets you away from actually coding, or in my case, fooling around on social media. But the reason you write these things down is to have a record of them, so you can refer back to them and say, yeah, 3 months ago, I had a meeting with Bill, and I discussed with Bill, here's what I'm trying to do. And Bill said, oh yeah, we should structure it this way. I made notes and said, oh, Bill said we should change the format of this configuration file from this more specific one with 10 fields to this very generic one with 4. And then when people were doing integration work, they assumed there were 10 fields when there were still only 4. And that's why this thing blew up when this team merged their patch into code, and it got deployed late on a Friday when people weren't particularly paying attention. Having this sort of record of what went on is also how you can start looking at as a senior level. Are you noticing some trends? Are there certain things that we as a team and we as a business are doing that constantly fail every time we try them? Start looking for common patterns. does the same thing happen? Is it the same person breaking things? Is it the same system that breaks every time we try to upgrade? Those give you places to look for opportunities to refactor, extend, or even eliminate if you can get rid of it, to make sure you don't want the same problems happening constantly. Sadly, writing things down is the best way to go back when things go wrong to analyze what happened. Because at a senior level, one of the things we love to do is tinker. When we want to refactor. This code that your co-worker wrote is terrible, and the only reason it's terrible is because you're not the one that wrote it. So clearly, you want to refactor it because you've learned so many more things. You're at a senior level. There's pressure on you to deliver. So you have decisions about refactoring. Are we going to refactor this? And when I'm talking about refactoring, what I really mean is that you are changing things behind the scenes without changing the existing functionality. If you change how the thing functions, that is actually a rewrite, is not a refactor. Having a really good test suite is the best defense you can have for refactoring, because a good test suite, and even have a good test suite, even if it's not automated, having a clearly defined way that you test everything, that you can do every single time you make a change, will go a long way towards making this sort of, I'm changing something because I found a new way to do something, or there's an updated dependency, or in some cases, I suddenly need to start changing where I'm writing data to. We're refactoring a system. This bit of the system that we're dealing with needs to behave the same way that we expect. It's just changed, where it's writing or where it's getting its information from. At a lower level, you're probably not doing a lot of refactoring. At a senior level, a lot of your job is going to be going back and something needs to be fixed because there's a bug, or something needs to be extended. Those are prime opportunities to look at this and say, does it need to be changed? Sometimes you want to change things just for the sake of changing, but most of the time, if you go back, what I talked about earlier, about from the business perspective, we're delivering business value. I know people don't like that. They would just want a program. It's like, no, we have to think about this from what the business wants. The business doesn't want you breaking anything that's already working. So when we're refactoring stuff, we don't want to break. But what about rewriting? Sometimes we are going to have to rewrite something. Sometimes the thing that we've built, it just doesn't work anymore. So then you have to start deciding, how are we going to rewrite this code? As a junior developer, you probably don't have to think about that too much. But now, again, that's that one level up in the vision. What is worth rewriting? What is not worth rewriting? Maybe sometimes it's like, we could rewrite this, but I know there's an upcoming feature request that's going to totally change this. So let's not bother rewriting this when we know it's going to actually be replaced by something brand new. A good example could be if you're migrating from on-premises servers to AWS. Maybe you have some code where you've been you're lucky enough to have some QA people, and the process for creating test environments for them has been manual. They have to bother somebody on the ops team to say, hey, can you configure the staging server so it has this version of the front end and this version of the back end, and I need the test database seeded with this data set. Maybe your ops people used to do that manually. You look at that and go, I really think this needs to be automated. I think in a perfect world, we could have a web-based interface that says, from a drop-down, pick this version of the front end, this version of the back end. Oh yeah, and use these data sets that we've configured ahead of time. Click a button, and some automation takes care of it. But if you know you're going to be moving, in the next, say, 3 to 4 months from on-premises up to the cloud, then maybe you say this needs to be fixed, but we can do it in a different way once we're up in the cloud. Maybe you're going with a Docker-centric setup in the cloud. Then when the time comes, you can spend some time, how do I Dockerize development environments? And then once I have Docker images of all my development environments, what tools can I use to create this web page where the QA person goes and says, I need this and this and this, and hit a button, and then you write a bunch of automation to do that, right? Rewrites are okay, just rewrites need to happen at the time when they need to happen, for lack of a better phrase. Not every rewrite is worth doing. Some of them are just, you're not going to get back a return of the impact on the business to what to the amount of work that you're going to have to do. There's lots of great things that I've wanted to do, and lots of things that would have definitely helped the companies that I was working for. But upon further analysis, once you start talking to the business people, you quickly realize you're never going to, the amount of effort that would go into fixing the problem, you never make it back in either improved sales, improved conversion, more users, whatever metrics the business is using to decide what success and failure is. Sometimes it's just not worth it. And of course, as a senior person, I can't get away from talking this about the senior developer's job is definitely going to be improving testing. Of course, I'm going to talk about testing. It would not be a grumpy talk for me without talking about testing. As a developer, senior person, if you don't already know how to write tests with a commonly used testing framework, you need to stop doing anything else and learn, how do I use these tools? My books are great for it. You don't necessarily have to buy my books to do it. At this point in the PHP community, if you are not writing automatable tests for your code, it used to be that these things were not easy to install, not easy to use, and the number of people who actually knew how to use them was very small. These days, I can almost guarantee you that any tool that you install using Composer has tests, and all the major frameworks all have test suites. At this point in time, there's no reason to not be writing tests. Now, how many tests to write? I can't tell you, right? I always tell people, if your application doesn't have any tests, we are going to start from a position of no tests, with the end goal being fully automated tests. But just because we don't have automated tests doesn't mean we shouldn't be testing. We can start off with manually testing things, and then we move from manually testing things. It could even just be you print out an email and have it in front of you, and it tells, here's the 10 things that we do to test that, signing up for a new account and paying for it works. Do those things manually. The idea would be, if you do these things manually, you're going to get sick of doing them manually and figure out, how do I get the computer to do it? So the next step is, maybe you write a shell script that pre-creates an account for you, and then that cuts down on the number of steps you have to do as part of the manual testing. Then the next step could be, great, I'm actually going to write some PHP unit tests to set up an account and run the code that would handle the purchase and verify that the account is correctly set up. That's great. Then the next step would be, okay, now I'm going to have a continuous integration environment that can automatically run these tests for it. Every time there's a change, it'll grab my code, check out the changes, run my test suite for me. And then, of course, as I mentioned, the ultimate goal is, if a change passes, it goes automatically gets deployed. So you'll have your change gets merged. Your continuous integration service picks up on a code change, checks out your change, applies it to the code, runs your test, everything passes, up it goes into production. You're taking something that used to be error prone, manual list of things to do, to a fully automated system, and this then opens up a whole another set of opportunities where, for a lot of places, deployments are stressful. I definitely worked at places where never deploy on Mondays, never deploy on Fridays. And when there's a deployment, we do it off business hours, and everyone involved needs to stick around in the office, just in case something goes wrong. I definitely ate a lot of free pizza and did a lot of late hours, but you don't need to do it that way anymore. Like I said, there was a time when all these tools were difficult to use and hard to configure, and not many people understood them. I think we're at the point where having your changes automatically flow from your development environment up into production is an achievable goal. It's not a fantasy, it's definitely achievable. So as a senior developer, your goal should always be convincing everybody else to say, how do we prove that the thing we've been asked to do works as expected? How do we prove a bug was fixed? How do we prove a new feature works as expected? How do we prove that a change to a bit of code, what if we've decided to add caching? How do I prove that caching is working as expected? You start asking all these questions, then you discover that there's a whole new universe of tools and approaches that will help you answer those questions. Another thing that I think as a senior developer that you can really help with is by improving developer tools. I am a humongous fan of creating tools specifically for developers to allow them to do their job easier. Dockerized development environments, I'm a huge fan of. For a particular framework, does the framework you're using have the ability to create custom command line scripts? Build out scripts to do common things that your developers have to do. Do you have the way to do a clean install of your dependencies? If one doesn't exist, create one. Do you have a way to clear the cache because you're getting a weird bug that only appears sometimes? Maybe the stuff is cached. Write something that clears the cache. I could go on and on. Automated deployments, automated code reviews. The list of things that you can do to make a developer's life easier are endless. As a senior developer, look at those things. I talked about it before. Look at friction. Look at what the developers, look what you're doing that irritates you about the process of programming. Look at listen to what your coworkers claim is bothering them. Are these things that we can improve? Should we maybe standardize on using the same IDE? I'm a happy PHP Storm user. It becomes easier when everybody else is using PHP Storm because you can now say, oh yeah, there's this feature. Just go turn this thing on. Or oh, you haven't configured this value for a PHP unit correctly. Go to this menu option here to this screen, add this parameter, and now the test can automatically run for you. Help improve the experience for your developers so that you can expend less mental energy remembering how to do something and more mental energy solving problems. I've talked about this before in other talks. Computers are really, really good at doing the same thing over and over again without complaining. Humans, not so much. We complain, we get resentful, we don't want to do the same task over and over again. If I can get the computer to do a task for me and I know it will be done the same way every time, I'm definitely going to investigate that. And overall, I want to just emphasize that when you've finally gotten to that point of being a senior developer, I know I've talked about a lot of different things. Some of them may be things you've heard of before. Some of them are things that you probably haven't heard of before. One of my favorite science fiction books is Dune. I'm looking forward to watching the upcoming movie. And Dune had this great thing of fear is the mind killer. And what it really says that fear is the thing that can stop you from doing something that you can actually do. There's lots of talk about imposter syndrome, and I think a lot of what goes into what some people label as imposter syndrome is actually just, in many ways, is anxiety about, can I actually do the tasks that have been set out in front of me? And again, there's often lots of tasks that I face. I'm like, I have no idea how I'm going to solve this particular problem. It looks unsolvable at first glance, but by falling back on all the skills I've accumulated over the years, and also, by talking to my coworkers, talking to my peers, talking to random people on social media when I ask for help, you quickly learn that you can take almost any problem and chop it down into a smaller set of problems, and you start solving those individual problems, and then all of a sudden the big thing gets solved. Because oftentimes this is what it can kind of look like when you're looking at, I'm just that little person on the bottom. I have this humongous problem that I'm trying to solve. Don't be afraid. Failure is like the default mode for programming. The only other job I can think of where failure is such a normal part is probably professional sports, where there's lots and lots of failure, but the success can be really, really great. When you become a senior developer, don't be afraid. There's a reason you're there doing this. You got this. I know it's like a more American style phrase, but you've got this. You can definitely do this. You're not as alone in trying to solve these problems as you think you are. There's a whole internet full of people who have either solved the problem you're facing or are in the process of solving the problem. You can, if you go and search, Stack Overflow is a great resource, for a reason. Almost any problem you've run into, somebody has solved it. And if they haven't solved that particular problem, maybe you can find someone who has solved a problem that sounds very close to what you're trying to solve, and you can take the lessons they learned and applied it to your own own problems you're trying to solve. Being a senior developer, it's the freedom that you get to have to, it is freedom to not have to worry about just solving one level of a problem. All of a sudden you get to have a say. And for me, that's always been the big thing. I always want to have a say in what it is that I'm doing. I want to be able to participate in the process of deciding what we're building, where we're building it, why we're building it, and hopefully how we're going to build it. Because I have found, shockingly, I never thought I would be this way, but I have found that when I solve problems for the business, I actually feel good that I've solved a problem. Not every problem as a developer that we have to solve will be directly related to the success of the business. But when you solve a problem, when you speed things up, and when the non-technical people notice that the problem has been solved, that is actually a good feeling. And that leads to getting more responsibility, more senior jobs, and more opportunities to sort of learn stuff. So that's all I have for this. So I encourage people, I know a lot of people aren't on social media. Twitter is actually the best way to get a hold of me. You can follow my performance art there. All those books that Neil talked about at the very beginning, they're all done through LeanPub. You can find that link there on LeanPub. Just search for my name on LeanPub and you'll find the books there. And I would be happy to answer questions that people have.
Okay, I'm just gonna turn my video back on. Thank you so much, Chris. Everybody at home, again, please give a massive round of applause. That was absolutely fantastic. And wow, I mean, you've sparked a huge conversation in the chat. We'll get to some of those. I mean, there are a lot of questions in there as well. I think, I mean, one question that I've got, and apologies if you covered this halfway through your talk, my sound cut out, and then my laptop dropped, disconnected all of my Bluetooth, and then Zoom turned the volume down to 0, and I was trying to debug that for ages. So please, Ben, if you already covered this, but I was thinking, is there a downside to companies hiring only senior people? Because a lot of companies in the UK do that. You know, you go in and they're only hiring seniors. Can there be too many cooks with too many different ideas and too many kind of approaches?
Absolutely. I think that is probably the, I mean, this is all anecdotal, but my own experiences have been that companies are attempting to shortcut the learning process on their own staff by only hiring senior people. And there are some problems that senior and more experienced developers can solve because, just because I know it sounds like a cop-out, right? That you need people who are used to working in, grindy enterprise environments, who are going to solve the problems effectively and communicate properly with the business people about it. The best way to get people like that is to actually train them, right? But where the pendulum swings back and forth, right, between how much are companies willing to pay for their employees to learn how to do new things. In the early I would say, like in the early 2000s, it definitely swang towards companies were happy to send people to conferences, to pay for books, to pay for tutorials. And now we've swung back the other way where companies are more or less expecting people to learn on their own time. And I mean, my personal feelings on this are like, you are definitely at risk of losing people if you are forcing them to spend their time not at work, getting better at work. So, I mean, there's an old joke that says, what if we pay to train people and they leave? And they're like, well, what if we don't train them and they stay, right? I think more and more companies would be so much better off if they would start thinking about programming as more of like an apprenticeship style thing, where we're going to bring in junior developers and then we set things up so the juniors can do work while being mentored by the senior people at the same time. And then you get that opportunity to bring somebody along who is maybe not necessarily as skilled as your senior people, but can actually solve the problems that the business needs solving. Like, there are definitely tasks that are, like, for lack of a better phrase, you're not paying senior developers to solve junior problems. And then when all you have are senior people, then they're going to form their own hierarchy no matter what. There will be the junior within the senior, and the expert and the senior within the seniors. If everybody is senior, nobody's senior. You're all the same level of experience. And there's some environments where that will work. But I think there are lots of environments where it simply doesn't. If you're responsible for hiring people where you work. You really need to start thinking about taking a more longer-term approach to the problems we're trying to solve, and hire juniors so that you can train them and lift them up. And then you're at the same time, you are protecting yourself against people leaving. How many companies have been ruined because they burn out the one person that understands how a key critical part of the business works? Where I'm working right now, there's a very, very knowledgeable person who understands how everything works. And if that person ever decides to take an extended vacation or leaves, the project as a whole is in jeopardy. But the company has let that happen by not understanding we need to have this pipeline of junior to intermediate to senior people there. You can't have one person who's the only person who understands how something works. And the best way to do that is to only ever hire seniors. Plus, it costs you so much more to hire a senior person because you're going to have the same amount of, it's going to take the same amount of time, despite what some people may want you to believe. It takes as long as a junior person to understand how something works as the senior does. Going into a thing cold, it's not like the senior person is going to understand things a lot faster. Where I am now, I'm in my fourth month of working there. It took 3 months just to understand how everything works. And this has nothing to do with my skill level with the code. This is just understanding everything that's going on. Who are the people that understand different portions of the system? How do I get in touch with them? Who do I talk to understand how something works? So hire juniors, train juniors. That way, from a business perspective, you are actually protecting your business by creating people by having people at all different skill levels who understand how it works. On the flip side, if you're the only senior person there, you're either going to get burnt out, or you can really leverage that to your advantage to get better benefits, better pay, more vacation time, all that sort of stuff that as senior developers, you get to that point where quality of life starts mattering. And if you're the only person that knows how to do something, you're either going to be worked to death or you're going to be fired the first chance that they can replace you with somebody else. Never be the only person that knows how to do something.
Okay, cool. There's a comment in here that made me chuckle. It says, "I promise I'll write at least one test this year." But the first actual question, we have, I think, is what is your opinion about ethical questions and problems that senior devs are facing? For example, gathering too much user information, etc. So kind of the morality around our jobs, I guess.
I'm a big believer in ethics when it comes to programming. I will share a little anecdote. My second programming job was working for a team that built an adult dating website. So I got to see up close and personal what happens when you sort of, if not go, when you bang up against them. What happens when your business is actively deceiving people, cheating people, that sort of thing. I think our industry as a whole has done a terrible job of instilling ethics in the people that work in it. I mean, I get it. There's ridiculous amounts of money to be made by building something and sticking it up on the internet. I get that. I see the rush. The two current trends that I see are the same sort of, getting into ethical questions of, are we exploiting or outright cheating people? I think about focusing on cryptocurrencies. I think about the focus on AI. I think about how we're trying to build systems where the people that run them are insulated from consequences. And I think that is the biggest issue. I have encouraged people who are working at places where they're like, I don't feel good, morally or ethically working on this thing. I encourage people to quit those jobs. I'm like, no amount of money can make up for cheating people. No amount of money can make up for lying to people about things. And I know that's very easy for me to say, as someone who has had a bazillion years of experience, who I'm very fortunate, I've built up a good network of people, that when it's time for me to move on to another job, I generally don't struggle to find a job. I understand that not everybody is in the same position. I understand that people are sometimes forced due to circumstance to take jobs, and maybe those jobs end up being, unethical or immoral or whatever. I think as a whole, our industry has done a terrible, terrible job of of asking people to think about the impact of the work um, that they're doing. Does Facebook pay really well? Yes, they do. Should you work for Facebook? My personal opinion is no. That the downside for what your employer is doing does not make up for the amount of money that you're making. I understand our society is at a point where money really matters. I want to be able to look. I want to be able to look at myself in a mirror and not have to twist myself into knots to justify the work that I'm doing. Where I'm working right now is we're doing an e-commerce site for a large American corporation. There's nothing unethical about what I'm doing. It's a very interesting problem to solve, but I've definitely turned down jobs where it was like this, to use a North American phrase, this is really skeevy, and I don't want to be involved in any of this stuff at all. Please think about the things that you're building, and think about how people are going to use them to abuse other people. We are too eager to build something interesting without thinking what happens when someone other than me has to use it. So like I said, the money's really good in building unethical things, which is an unfortunate downside to it. But yes, please think about ethics. Think about these things we're building. Who's going to use them? How are they going to be abused? And ask yourself. If you don't care, fine, go work at these places. If you really don't care, I'm not going to try to ostracize you. I'm just like, it's not for me. I would not want to work for a place where if people ask me what I do for a living, I'm reluctant to tell them what it is I'm doing. That's usually the surest sign that you're probably not working for the best sort of place. Because for many years, I didn't tell anybody that I worked for that dating place, because after working there for a while, I'm like, I need this job, but man, I do not like the work that I'm doing.
I think the kind of go-to example, I think, for the ethical thing about with developers as well, isn't it, is when Volkswagen had those magical cars that had zero emissions on a 2-litre engine. And of course, Volkswagen got found out, and there was they'd lied to all of their customers who'd bought them because of their green credentials, and it was the developers, the engineers, who bore the brunt of that and ended up in trouble, because it's easy for an unethical company just to say, as a rogue developer, and you take the blame for anything. But we've got a good you talk about employability, and that kind of leads into the next question, I think, here. So this is Abdullah. He's got a question to you. So he's Abdullah's from Cameroon. Says, question to you. I rate myself as an intermediate programmer, but I have problems getting employed. What can I do to remedy this? And I think later on says that it's I think later on in the chat says that pay isn't particularly great there, and it's maybe oversaturated in the market. So what how is there any advice that you have to increase employability?
I know for me, and again, I tend to speak about like what worked for me, and I caution people that what worked for me may not be repeatable. Some of what I did was due to time frame. Some of it has been due to opportunity. Some of it has been due to I'm in Canada as opposed to Africa or Europe. I think what has worked for me was two things. Number one, picking a niche and saying, in addition, I want to be the programmer who's known for X. In my case, I stumbled upon testing. At a dating website that I was working for, we had a disastrous release. And during the postmortem, where we all got yelled at because everything went terribly, someone asked, like, doesn't anyone ever check to make sure that this stuff works? And I was not working at home at that time. I had a very long train ride back and forth. And so I started thinking about this is a legitimate question. What could we have done to make sure this stuff worked? How are we testing things? And then as fortune would have it, when we came back on the Monday after getting yelled at the Friday, the project manager dragged me into his office, and we were talking about how terrible everything went. And he handed me a copy of one of the very early extreme programming books. This tells you how long ago this was. And said, take this book home and read this book this week. I think there's some stuff in here that that if we start doing some versions of these things, I think we can start solving some of these problems. And in there was the whole section on unit testing. And like, you know, that joke about the, you know, the light bulb over your head and the light goes on. I read that on the train ride going home. And I remember blurting out loud, like, I mean, I'm going to swear, I remember blurting out, like, holy fuck. Like I said this like really loud when I was on the train, and like everyone turned around and was like staring at me because, you know, you don't talk on the train. That's just nonsense. But I decided then that this was something that I felt like could separate me from everybody else, because nobody else that I knew was specializing in testing. So to get back to the question from this person, I think the key is you have to do some research and say, okay, all the developers who are like me, what are the tools that they're using and what are the problems they're trying to solve? If I wish to stand out from that crowd, what skills do I need to learn? And I mean, this isn't really a thing about like getting paid more is nice, but I think the key to like advancing up that progression of where I talked about, you know, Neil, we talked about it before, programming as the job, programming as the career, and programming as the calling, which is what we're doing as speakers and evangelists and all that stuff. The way you move from programming as the job, and it's a good paying job in most places, to programming as the career is finding out what are the parts of programming I like and want to know more about, and then start doing more of them. So, you know, we all know the hiring process sucks. Someone's going to look at your resume for like, I don't know, 15, 20 seconds before deciding to move on. You want to be building a skill set that says, hey, I can do what everybody else around here does, but here's this other thing that I do better than everybody else. And then you also need to be able to provide proof of that. Blogging is a great way to do that. YouTube videos demonstrating how to use tools is great. Giving conference talks, user group talks, that sort of stuff. You always want to be saying, I can do what everyone else around here does, but I can do this one thing that they can't. And then that becomes the thing that you use to convince people to hire you. Testing was the thing that worked for me. You know, other people came up, you know, with other niche skills, that niche parts of programming that helped them. Testing was the thing that literally took me from programming as a job to programming as a career. So find something that you're interested in, learn more, and then that becomes the thing that you sell yourself as, oh, I can do it. I can do what all these other people do, but here's the thing that I can do that they can't. And then how this can help the person who's going to hire you to work for them. I hope that helps. I mean, it worked for me. Is it repeatable? I hope so. It sounds like it's repeatable, but that's what I generally advise people to do these days.
Yeah, I think that kind of resonates. I don't know if you're aware of the Breath serverless PHP project.
Yep,
but
very familiar with it.
Yeah, cool. I mean, I first got involved in that like very, very kind of early on, and I don't do anything really with it now to which is a massive shame. But once I started doing talks around that, and I really kind of fell in love with the project, I suddenly noticed that people were taking notice of me, and I was kind of certainly in my local sphere, so almost a go-to person. People come to me with questions, and that was great. And I know Tobias was on the, I don't know if Tobias is still here or not, but Tobias has taken that project with Matthew Napoli and kind of really accelerated the thing. So I should get back into it. But yeah, I think that's a really good thing, because I started getting involved with that project, and all of a sudden I saw these kind of doors opening, and I was giving talks about it and everything else. So Piotr asks, would you consider a good testing suite better than documentation? So front-end API contracts, etc.
Well, that's a good question. In many ways, a good test suite actually acts as documentation, because it can show you how to actually use the code at that low level, because every test, chances are the code inside the test is very similar to what the application itself is using, where the documentation, the thing that tests can't document for you is the other things that you need to learn about. How do I install the application is usually not in the tests. You know, and high-level strategy stuff. Why do we do it this way? That's always the question that I like to ask about. Why was this decision made? And by understanding why, it usually can tell you, okay, again, like what I talked about in the talk, how do I get from here to there? And you know, documentation for the project is one way to do it. I think what the test suite protects you in a different way from documentation. Documentation can show you, at the time the documentation was written, how something works. If the documentation is not updated, that can be problematic. Definitely can find lots of examples of where the documentation lags behind how the thing actually works. I think from just a pure trying to get things done as a programmer perspective, a good test suite is invaluable because it is actual examples on how to do something. And then when you get to the case where you're having to extend things or refactor things, you should have enough code examples from the tests themselves to say, oh, okay, now I understand how I call that thing. Or oh, there's this weird optional parameter. When do we use it? Okay, I found a sample of when to use it. So test suites are really good. Accurate documentation is really good. The two of them together is perfect. I have found my experience have been usually get one or the other. You either get really good documentation on how the system works, or you get a really good test suite. Of course, being test-centric, I prefer to having a good test suite because my brain has been warped by years of doing test-driven development. That I tend to do this sort of thing where one little change, prove the change works. Another little change, prove the change works. That is a lot harder to do if all I have is documentation instead of a test suite.
Okay, yeah, and I think I mean I'm a big fan of TDD, and I think it's definitely possible to write your tests in a way that describe I mean Kent Beck would say that anyway, writing the tests in a way that describe the behavior, right? And then you've got this kind of documentation about what the system should be doing rather than just the state of what it does. But a lot of the intent is then encapsulated right within that test suite in the middle, and that a well-designed test suite will kind of reduce the need for too much documentation. And we've still got a lot. I'm going to pick maybe a handful of questions. We've got some. I
have lots and lots of time, Neil. So keep coming with the questions.
Cool. Okay, fine. Let's keep going then. Okay, so Sam says, as a senior dev, I want to improve quality in an environment that's plagued by heavy time and money constraints. Are there any tips on how to propagate change?
So this is a good one. I've run into this, and so I think I have to tell a little story that sort of illustrates how this works. The time and money thing is real, right? We only have so much time, and there's only so much money. But I think what has to be done is that you have to make the case to the people who decide how much time is going to be spent and how much money is to be spent, the value of quality. The story that I've used that resonates really well with both technical people and non-technical people is that we have to start thinking about things in terms of how much is it going to cost to fix a problem in terms of time and money. The cheapest time to fix a problem is when the developer is working on the code. Right? So if we think about a bug making it all the way up into production. So kind of what happens. So the first thing is the developer is working on a ticket. They create something. If they don't have a test suite, they may have created a bug. So they don't find the bug. So the bug goes to maybe you're lucky enough to have code review. A reviewer finds the bug. So now the bug has changed from costing just X in terms of developer time to 2X. Right? That's fair. So the developer goes back, fixes the bug. Then the reviewer has to look at it and go, great, I don't see the problem anymore. Then that maybe you have a staging environment and you have one or two really overworked QA people. QA person finds a problem. So maybe now the cost to have fixed this bug is now 4 times the developer's cost, because now it goes back. I have to fix the problem. The reviewer has to review the change and make sure the change still looks okay. Now our QA person has to find the problem. So then maybe now finally it goes out of staging, it goes into production. Now, how much could a bug that makes it into production cost to fix? Who knows? It could be X time, right? It could be 10 times. It could be a database migration that wipes out your production database. It could be you break the key metric that the business relies on is people signing up for accounts. Maybe you accidentally break the login process. Maybe you accidentally break the sign-up process. Maybe you've broken how customer dashboards work. Maybe you inadvertently broke reporting, right? All of a sudden, you now could go from this thing could cost 10x, 100x, 1,000 times developer time. Plus, then you have the added stress of Most companies, when something goes wrong, sadly, people panic, and you have multiple people in parallel trying to solve the problem when probably you only need one person solving the problem. So you have this the biggest lesson is the cost to fix a bug that makes it into production is unknown, and it is risky to have unknown bugs make it into production, because who knows what it's going to take to fix it. What if you go back to my thing, what if you run a database migration in production and it destroys your production database? What happens if your latest backup is a week old or a month old, or because you never anticipated this would be a problem, you have no database backups? You've ruined the business. You've literally ruined the business. And all because why? Because as an organization, you did not insist on a process of finding problems before they make it up into production. And automated tests are definitely one way to do it. Code reviews are a great way to do it. But at the end of the day, what you're trying to do is we need to set a process that said everything before it goes up into production, we need to know it works exactly as intended, and that it is going to work exactly as intended in production. And if you can't answer that question, you are taking a humongous risk. Maybe it's not a problem. Maybe you break something that doesn't get used very often. Maybe you break something that the users don't really care about. But it's a level of risk. It's all about, it's really about managing risk. You're trying to move the cost of solving a problem from the most expensive part of the process, which is production, with everybody panicking and people being shouted at to fix the problem yesterday, to the cheapest, lowest, hopefully calmest part of the process, when the developer has their editor open and a terminal open and they're making a change and running a test and making a change and running a test. That is the lesson to tell. Only the most I don't like to call people stupid, but it's not about stupidity. It's about ignorance and not understanding the side effects of what you're doing. Only the most ignorant person will hear this scenario and think, no, we don't need to change anything, or no, we don't need to slow down. Maybe it's as little as the slow down to start insisting we start coming up with a process for testing costs you 1 day a week. Okay, so maybe your developers are 80% as productive as before, but the chance of you getting that that black swan event happening in production, where a change just breaks things to the point where you literally have to throw up the sorry, something's not working, and it takes like 5-6 hours to get things back to where they were before. That is the thing that you want to avoid. This is why I spend all this time telling people, write tests, create automation, have an easy way to both deploy things and roll things back when there's a problem. You're trying to make it so that in production, you have the fewest problems possible. There's no such thing as a bug-free application, because we're humans writing things. We're going to make mistakes. We're not going to sometimes realize those mistakes until they get up into production. We're trying to make it so that the chance of a showstopper bug is zero. That's what we want. We don't want showstopper. We want easy fixes. We want to be like, oh, the header's in the wrong place, so the front-end developer fixes it. We review the change, QA verify it works, and it goes up into production. When you have these processes in place, you can't start skipping them. You can't start force pushing. You can't start ignoring your QA people. Your goal is, I always want to know everything that I'm working on, is it solving the problem? Is it behaving the way that I expect? So it's the time and money thing. You have to point out, to get back to the original question, you have to point out how much it is costing the business to let shitty things end up in production, when there is a low-cost way to ensure that it doesn't happen. We're trying to prevent showstopper bugs. So that's what you tell people. It's costing us $1,000 a week for these problems. It'll cost us less than $1,000 a week to put a test suite together. That's the argument to be made. It's about money. Only really ignorant people don't care about how much bugs cost the business. And I don't want to get started on the, developers shouldn't create bugs. That's nonsense, because we don't always know the constraints under which our stuff is going to be used. Test suites plus writing defensive code is really the only way to do that. So I get upset about that. Testing isn't worth the money. It's always worth it, because it will save your company money, instead of just saying go, 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 push, push, push. That's when mistakes happen. People get processes in place and then they skip them.
I think, yeah, I mean, there's another question from Ram here, on a very similar vein, right? So the question we just answered, working environment that's played by that within a company, and then Ram asks that how would you tackle with the client the need of having quality in the project when they're pushing you to deliver fast? But I think it's probably similar, isn't it?
I think the biggest mistake that people make who are doing client work is actually letting the client know that there's testing being done. Testing is just part of the development process. I don't think you should ever be putting a line item on an invoice for a client that here's how much it costs you for the test. The tests just become something that you do. Now, I get client pressures. I understand that, right? I 100% get that. At the same time, there has to be a way to push back and say, we're going too fast. There are going to be too many problems, and the client is going to be unhappy. The client is the one you have to make happy within reasonable limits, right? I haven't done a ton of agency work, but I do know people who have, and those who care about the quality stuff have said the biggest change that they just did was two things. You fire unreasonable clients, and then you simply make testing just part of the development process. You never tell the client, we're almost done with the tests. The client doesn't care. The people who use your application, they don't care that you've tested it. They really don't. I know as programmers, we want to brag about, I built this website with this version of the framework and these tools. And everything. The people who use it, unless you are creating tools for other developers, they don't care. They really don't care. So your goal is to solve a problem for somebody. Testing becomes just something that you do, and also if you can, fire unreasonable clients, because unreasonable clients usually don't pay well, and they're going to make you miserable and monopolize your time. So never tell a client we're just testing things. Never tell them that. It's not a line item. It's just this is how we build things. Like, why does it cost more, and why is it taking longer than it used to? It's just because it does. And I think that's the you arguing with a client over unit tests sounds like a great way to end up burnt out.
Yeah. So a question here. So for someone who's never tested their code, what should they do as a beginner? It's the big thing, right? How do you start with unit testing? For me, it was a big kind of thing.
Well,
being able to start.
Yeah. Well, actually, you don't actually start with unit testing. You start by changing the mindset. The mindset starts off with, how do I prove that the thing I'm doing works as expected? Now, in many cases, we start off with it's totally manual. You have to test the web app itself, right? So, but that's where you start. The automating of it is several levels up, right? The first thing is understand that it's always the mindset becomes, how do I prove the thing that I'm doing works as expected? Now, again, I talk about the old days, right? To make it sound like I'm a bazillion years old. I'm not gonna lie, I'm 50 years old. I got a actually very late start in programming compared to most people. I didn't get my first paid programming job until my late 20s, right? So I came along at a much different time than a lot of people. So, but the one thing that hasn't changed is that, these days, there was a long time where I was literally the only person in the PHP community other than Sebastian Bergman, who created PHP Unit, talking about testing code. I am no longer that person anymore. There are lots and lots of people who can tell you how to test your code. But the biggest problem is that learning to test your code is not something you can do alone, unfortunately. I think it's almost impossible to learn how to use all these tools by yourself. So this is why you're essentially stalling for time. You're trying to create a culture of caring about proving what I did works as expected. It starts off with the manual testing. Then the next step is okay, if I wanted to automate this manual thing, what does that look like in a perfect world? I talk about it all this time and people roll their eyes, but we start off with, if everything was perfect, how would this work? And then you start working backwards that, I don't have a perfect world. Here's what I have. How do I make this work? Now, maybe you've never written a unit test. That's fine. but you can definitely find out how do the first step is like, okay, how do I install PHP unit alongside my code? How do I do that? That's a pretty easy question to answer because there's multiple ways to do that. We can do it via Composer. We could do it via what Sebastian recommends, which is downloading a FAR file, an FAR, PHP archive file that has PHP unit in it. Okay, I can do that. That's great. That's the first step. Okay, so then at the same time, we're still testing things manually. Okay, so what does a unit test look like? How would I write like a unit test not related to the code that I've written? You can find lots of examples on how to do that. You may have to take some time away from the task at hand to like write a really simple test that seems stupid, but how do I write a unit test? Well, unit tests look like this. Okay, great. So how do I run the unit test? Well, you use PHP unit and you run it from the command line and you aim it, you have a configuration file, and then you aim it and you let it run and it'll find your test and run it. Great, but at the same time, we're still building on that thing. How do I prove? Then, but the thing that's usually the hardest is, okay, how do I write a test for my existing code? And then that is where all the problems usually start, because chances are your code is not testable. It's not written with this sort of ability to isolate behavior, right? Like, we have code. It's like, how can I test this? How do I overwrite? How do I create? Is this going to talk to the database? How is it going to talk to the database? Oh, I have this. I have to create oh, there's a foo equals new something. Okay, but I can't do that. How do I create this thing at runtime? But those are things that sadly you need to pair with someone who has done that before. So my advice is actually, it's a bit of self-serving one too, but if you want to learn how to write unit tests, you need to hire someone who's done it before. And then that person's, or hire a consultant or hire someone just temporarily to say, I need someone that knows how to write unit tests. I need them to work with my team. And maybe you only need a couple, maybe you only need a couple months out of this person. But that's what you need. Sadly, as awesome as I think my books are at teaching people how to do this stuff, you need to not me specifically, because I can't work for everybody side by side because I have a day job, but you really need to get somebody to work with you who has done this before. Like I said, for many, many years, there was a very small community of people who knew to do this on the PHP side. Now, thankfully, we've really gotten to the point where testing is something that pretty much every major PHP-centric project is doing. Whatever framework you're using, chances are it has a test suite, and there'll be examples on how to do it. But you really need to find someone. You need to find someone to teach you how to write tests, and then you can start teaching the people you work with how to write those tests. Maybe it's a course. Maybe it's a workshop. Maybe it's you have to. Again, I don't encourage people to spend their time away from outside of work, essentially working. But at the beginning, maybe that's what you need to do. Maybe you need to find someone local or find someone in the same time zone as you who's like, I want someone to teach me how to write some tests. Who can mentor me? I used to do a lot of that mentoring stuff, but again, I've switched to a different phase of my career where I'm concentrating on quality of life issues at this point. So, but that's how I helped out numerous people who asked and said, I want to learn how to do this stuff. Who has some time? And I would spend a couple of nights. Or I'd say, hey, look, I'm gonna. If your company can spring for it, I'm going to a conference where I'm giving a tutorial, where I'm doing 8 hours of teaching people how to write tests. Maybe you can convince your company to let you come to that. You'll learn enough at that event that you can then go back and start getting your other coworkers to write tests, and then then you just start building on it. Because again, people laugh at this, but there was a time when I was the only one doing conference talks about testing. I'm so happy that I'm no longer that way, and that there are lots and lots of resources online. For whatever framework that you're using, there is somebody who can tell you how to write tests for it. So find someone who can commit a bunch of time to teach you how to do it. You can't learn this stuff on your own, unfortunately. I did, and it took me like 10 years to get to the point where I could teach people about it. That gives you an idea of how long it kind of takes.
Yeah, I mean, I worked. I worked at a company where I think the testing was absolutely spot on. I learned so much from my time at that company that I feel that I can confidently move on now and help other people with testing. And eventually you get to kind of spot where people have taken a TDD approach versus a test last approach, purely because of the way the tests are written or how brittle or flexible they are.
Yeah, absolutely. You're absolutely spot on there, Neil. I can definitely tell TDD versus test after. It's once you've done it enough times, as soon as you open up, like, oh yeah, I can see. Just in how things are named and how the code itself works, the number of dependencies, all that stuff. You very quickly you learn like the shape, right? You learn like tests that were written afterwards, they kind of look the same, and tests that were written as part of TDD, they kind of look the same. It's funny to, like, when you get to that point, you definitely realize, yes, I can start seeing this code. Are you going to start looking at code and understand that it was designed with testing in mind instead of the testing being bolted on afterwards?
Yeah, yeah. This should be an easy question here. Are you using PHP Stan or Psalm?
I have used both. The project I am working on uses Psalm. I am very happy with those tools. My latest book, which isn't 100% finished, sort of talks about tools that complement testing practices really well. And I think the whole sort of, I think the static analysis is like the next sort of leap forward for quality tooling in PHP. I say to people, pick one. It doesn't matter which one. Pick one, run with it. They're both kind of the same. Install it, let it scan your code, start at the lowest level, fix all the things that it finds, and keep cranking it up until you get to the highest level. And the reason to look at those tools, for people who are kind of wondering what's the big deal about static analysis, is that it's another layer of protection for your code. PHP being a dynamically typed language, it's never going to be a compiled language. So all the people who think PHP is becoming Java, you're wrong. We're never going to get a compiler. But what it does is it helps you create intent in your code, and it eliminates a whole series of bugs and weird behavior in your code, because Psalm and PHP Stan force you to be declarative about what you're doing, to say up front, this thing is this type of object, this variable is going to hold this sort of data, and also I'm using this particular language construct instead of this other one, because this one that the tool suggests is much clearer in what it's trying to do. Your intent in the code matters. You want to be able to have somebody else come in and look at what you're doing and be able to figure it out. PHP Stan versus Psalm, I don't care. Pick one, run with it. It will help you write better code and eliminate a bunch of problems that I used to have to write tests for, but now I just let the static code analyzer find those problems for me.
Okay. Question here, actually, that I was wondering myself as well. Where did you get your T-shirt from?
Oh, this one, PHP Unit or Die. A Canadian gentleman bought it for me a number of years ago. It's a one-off as far as I know. I have a couple of these. I have a PHP Unit or Die. I have a Too Lazy to Write Test shirt. Yeah, sorry, I think this is a one-off. I don't know if anyone else is selling it, but yeah, PHP Unit or Die. I only wear this when I'm programming, because I think out in the general public, wearing a t-shirt that says something or die is probably going to generate more questions than I feel like dealing with.
Okay. Question here, should a senior developer be a talkative person?
I mean, it helps. I mean, I do work with people. I have worked in the past with people who I would label as introverts, but get very excited when they're talking about technology. Do you have to be talkative? No, I don't. I mean, like I said, it helps, but I think more than anything else, being able to clearly communicate. If talking's not your thing, then you need to write things down. You need to create documents, wikis, really well-written commit messages, really clear issues. If you're using like an issue tracker, really clear responses and questions in tickets. If you're like using Jira or something like that. Being talkative is okay, but you can clearly communicate without being taught. If you don't want people coming over and talking to you, that's fine. But you have to be able to communicate what it is that they want. And also the ability to communicate also means understanding when the answer you've been given isn't enough, or understanding that you need to ask different questions. So I'm talkative. That has been an advantage for me. I definitely know there are more introverted programmers who are very smart and can answer your questions for you. They just don't do it by talking. They do it through email. They do it through GitHub issues. They do it through pull requests. They do it through documentation. But either you're going to blather on endlessly to people like I do about things, or you're going to have to write it all down. Just pick one and run with it.
Okay, I think the last question here then is going to be, so from Jurica, do you see some new trends that are there? So bear me a second. Do you see some new trends that are there, are only a few people talking about as unit testing 10 years ago? So I guess that's, so do you see some sort of emerging trends?
I think in some ways, like unit testing has become like a mature, stable technology. So the biggest trend that I saw that is now also, I feel like a solved thing is how do we move the automated running of tests from my own environment up into build services? So when GitHub Actions, oh my God, and now I'm blanking on the one that used to be free and then they got bought by somebody and kicked all the free people off. Oh my God, my brain is forgetting. But yeah, the rise of build servers, which mimic what you would do locally to run your tests, that was kind of like the last big trend. I think we're at a period now of refinement and consolidation. I know that I see a lot of people focusing on building tools that sit on top of PHP Unit. Pest is the one that comes to mind that has picked up a lot of traction. And let's be honest here, Pest's popularity is due to Laravel's popularity. It's not that Pest is a superior or easier to use tool. It's just a different syntax for writing your tests. And there's been other tools that have done the same thing. They're sitting on top of PHP Unit. I don't think anything new for unit testing. I can't see anything new. We've already covered everything that you need to know about unit testing. I think if there's one thing to think about, if people are looking to become that expert in the niche, I think the thing to look at is how do we build serverless stuff in a way that is easily testable, and understanding how do I take, I know Amazon being the key one here, but other providers, Azure has its own, Microsoft has its own serverless offerings, Google has its own serverless offerings, Amazon is probably the biggest. You have to start thinking about how do I duplicate a production-like serverless environment locally. So once you start answering that question, then you start thinking about, okay, if I have these serverless methods, how do I test them in such a way that I'm confident that when they're run in a production environment, they're going to behave the same way? So you have to look at, well, what are they doing? Well, I need to be able to call this thing and spin up everything that I need. Do I need a database? How do I simulate, what do I need to do to get the database in place for a serverless environment? That sort of thing. So I don't think anything new, I think we've kind of reached, we're going to do, there's nothing new about unit testing anymore. I think it's more like environments that the tests need to run in. If you want to make that serious money as a consultant, I think you would serve you well to say, how can I show people how to write serverless stuff and test it so that when it goes up into production, it works exactly the way that they expect? Also, another little hint for people too, they're looking at stuff, start becoming familiar with mutation testing tools. Mutation testing is an interesting idea where you're flipping the testing thing on its head. The mutation testing tools scan in your code and start modifying things in your code. Then they run your tests with the assumption that if I change the code, the test should fail. If I change the code and the test doesn't fail, my test probably isn't good enough. So I think sort of tools that complement unit testing are the next thing to worry about. Infection is the tool to look at for PHP folks. Become the expert, become the thing that's the thing that allows you to say, hey, I know how to do what everybody else does, but I also know how to do this. Infection is good. Figure out how to convince people, how can I test serverless stuff? Because the time to switch to serverless was probably yesterday, but if you're going to do it now, you definitely need to say, how do I verify all my serverless code is behaving the way that I expect?
Yeah. So Alistair commented that Travis CI is the
Travis, that's the one. Yes, thank you. I could not remember. But yeah, the project that I work on right now uses GitLab's version of Actions. Same thing. I feel like that was the last sort of really big thing that we layered on top of tests was an independent source of running our tests and something that is listening to changes and then running everything for us. So it used to be we used to have to run all those tests manually. I mean, I experimented with build servers back in 2002, 2003. So that's almost 20 years old, right? That whole sort of technology. But now it's like, companies like GitHub have made that super simple to have that build service through GitHub Actions. To do the stuff that used to require 6 months to set up, you get it done in an afternoon. So I consider that a humongous victory for programming as a whole.
Yeah. Okay. So do we have time for 2 more questions?
I can keep going until 5 p.m. my time. So I got about 15 more minutes.
Okay. Okay, so what do you think about tests that tests whether some class has tests to cover it? So I think we're talking about code coverage, or unless there's anything other than, is there such thing as a set of tests that would fail otherwise?
There is an open source project that I used to do all the development work for, and I don't do it anymore. We used some PHP code sniffer rules that said, we have a standardized way of naming our tests based on the code that it's testing. And then it would look we'd write a custom PHP code sniffer rule that would scan the code base and look and say, do I have a test? That is all, like, we talk about automating that. That is part of that whole sort of process of, like, we start off with manually doing quality things and then we start automating them. As a reviewer, part of the code review process at the beginning could definitely be, where's the test? If there's no test, the merge request is rejected. Go back and work on some tests. So yeah, there are definitely ways to create custom code linting rules that will look for tests. But then you have to start getting into standardizing on how we name our things, what namespaces are we using, and all that sort of stuff. And again, those all go to, like, back to a series of processes that we follow and never skip. So yes, you can write code that says, do I have a test for a particular bit of code? And then it's weird that you can use a linter to do it, but that is one way to do it. So I know that many times I would get lazy and forget to name a test properly, and this tool would say, we're missing a test. I'm like, I wrote a test, and then I realized, oh, I named it the wrong thing. So we'll just rename it and rerun the tool. So yes, PHP Code Sniffer can definitely do that.
Okay, I think if you are using a TDD approach, then I mean, ultimately, if you're doing TDD, then you'd have 100% coverage anyway, because you'd never write a line of code without having a test. I find sometimes, I mean, personally, I find that if you have a convention for naming tests, then that becomes too restrictive, or you don't think clearly about the behavior of the system that you're writing. You think too granularly maybe about the class that you're testing. So I would think that probably, or it has potential to introduce problems of its own, right? Is that?
No, I can see that. I mean, no, I can definitely see that. I think though, the benefit of, like, enforcing tests have to accompany the code that you're writing. That's really the thing that you're going for. You can either automate it, or you can make it a more manual thing that happens as part of your code review process. As a related thing, in terms of quality, I think the number one thing that you can do if you don't have any tests in place is insist on code reviews, and insist on the code reviews having the person who wrote the code explaining how to prove that the thing works. That's, again, everything comes back to, I want to verify that this application is behaving in a way that I expect. And that's always the goal. 100% code coverage is nice. not always necessary. But at the same time, I also tell people, like, when you're getting into this process, the first thing that you're doing when you say, okay, I want to write tests, the first thing should be identify all the things that are critical that have to work every single time an update to your application in production happens. Then those are the things you go about figuring, how do I prove that? Of course, it is a lie if someone says to you everything has to work. That is not true. It's definitely not true. Any application can have parts of it that are temporarily not working. But at the same time, like, what's critical that has to work every single time? Then you focus your testing efforts, manual or otherwise, on verifying every time I change something, what are the 6 parts of the app that have to work? And if someone, for the time being, manually verifies all 6 parts, well, then that's what has to be done. And hopefully you'll feel that pain enough where you'll invest the time to automate it.
Okay. So this could be the last question here from Piotr. How would you explain the difference between unit tests and component tests? I've noticed that lots of people think that PHP unit are unit tests.
Okay, so I think also what this needs to do is we need to stop thinking about tests in terms of unit integration and, I don't know, behavioral or functional. I think what we need to start, I'm sure that some people have seen that, like, the testing pyramid, which communicates somehow this idea that for every functional test, we should have X number, we should have some ratio of integration tests, and for every integration test, we should have some number of unit tests. I think what we really need to start doing is flip that on its head and think of all these tests as a series of sieves and filters, where the idea is that we're going to write a bunch of tests to look for behavior. And then any problems that get through are ones that we couldn't find with that particular style of test. And then you want another layer of filters that is, so if we look at unit versus integration versus functional, right? Unit is ideally behavior of some block of code behaves the way that I expect. Integration tests are generally two bits of code, 2 different bits of code talk to each other correctly. And then the functional tests are the application, parts of the application behave as we expect, because the idea is that parts of the application are going to use multiple bits of code. So if they talk correctly to each other, chances are the integration tests, which are looking at a much lower level, are correct. And if the integration tests tend to work okay, then the unit tests should work okay. The naming thing is really what the problem happens. But we have to think of them as like a series of filters, that we have a bunch of tests, and any bugs that get through it were ones that we could never find with like, there'll be bugs that you can't find with unit tests. And then there'll be bugs that you can't find with integration tests. And then there'll be bugs that you can't find with functional tests, just simply because, we are humans. We are not robots. Don't worry, people. Robots aren't replacing us anytime soon. As a firm believer as I am in automation, I see lots of things where computers are never ever going. Well, they're not, I look at it this way: they're not going to replace me before I stop working, so I'm not going to worry about it that much. But we're always trying to find what behavior can we prove is working as great. A really good unit test suite with really good code coverage probably means you're not going to have to write too many integration tests. And consequently, if you have a high level of confidence of your unit tests, you're probably not going to need an extensive functional test suite, but you do need all of them. You do need someone testing, does the application work? You do need someone testing, do these 2 modules, when they talk to each other under something close to real world conditions, do they behave correctly? You're still going to need those. You're probably just not going to need as many of them, but you have to just think of it as, stop thinking about the pyramid. Think of the tests as filters. We're trying to catch a whole bunch of problems. Unit tests are, we're trying to use the unit tests to design what we've been building and thinking up front a bit about how these things talk to each other. And the idea is that if we are consistent in how we write unit tests, then we're probably not going to need as many integration tests, and they're probably not going to need as many functional tests, but we're still going to need them. But yeah, don't think about pyramids. A series of sieves and filters is a much better way to think about it. And I think also that we spend far too much time trying to automate things that should probably just be done manually before they go to production, especially testing the application itself. If the critical thing is people have to be able to log in and see a series of tasks, I don't see the point in standing up browser automation to make it happen. It's just not worth it. Just, have somebody whose job is every time you release to production, they go log in and make sure there's no errors. I mean, to me, that seems like a much better use of our time than I have to learn how to use Selenium and stand up different environments and different browsers. As fun and as productive as that can be from a business perspective, it's usually a huge waste of time and money.
Okay. So very quickly, just before we close off, still a one-word answer on this one: London or Detroit?
London or Detroit in terms of what?
Testing style.
I go back and forth. These days, my personal opinion is use the real thing as much as possible, but don't be afraid to use mocks. I think when you approach it that way, your coding style changes, and you discover that the key code that is easily testable is ones where you're passing little bits and packets around everywhere. London versus Detroit, I don't know, like mocks are fine. Just like think about why you're using them. If you're using them because someone told you to use them, that's probably the wrong reason. If you always use the real thing because somebody told you, that again is probably the wrong reason. There are definitely applications where I can do everything, use the real thing, except I have to mock a third-party API call, or I have to mock a database call because I can't, the process of getting a usable database snapshot is too hard. So the answer is always, it depends. But I generally tell people, use the real thing if you can, but be aware of the edges of your application where you have to poke outside of that to create a mock to behave a specific way.